Hey there, welcome back to section 2 for chapter 11. We're going to be talking about areas of trapezoids, rhombi, and kites. We're going to have objectives today to find the area of trapezoids and then find areas of rhombi and kites. And the reason why rhombi and kites are together is because a rhombus and a kite have the same shape. All right, so let's start off with talking about area of a trapezoid. Area of a trapezoid is going to have the formula of 1/2 height times the sum of the bases. And if we go and label here, we have base 1. We're going to just call the short one base 1 and the long one base 2. And remember, our height is perpendicular to our base. And we always can change the 1/2 to a divide by 2. So the height times the sum of the bases, divide by 2. So let's go ahead and look here at the first one. The area of the steel used to make the razor blade show. Okay, we're going to find that area. We have our height, we have our base 1, and our base 2. So we're going to take our height times the sum of the bases and divide by 2. Go ahead and type that into your calculator and find us an area. All right, when you did that, you should end up with 2.75 centimeters squared. Remember, it's area, so we're talking about squared area. All right. Number 2, one of Ella's trapezoid-shaped handbags is shown. Find the amount of material used to make the side shown. All right, so we have our bases, but we need our height. But before we can find our height, we need to know what this bottom portion here is, because we're going to use that right triangle there in Pythagorean theorem. So if I drop down a line here, I know that this distance between my dotted lines is 28, and the other two sides have to be equal. So if I take 58 and I minus out that 28, I'm left with 30. And that 30 needs to be split between these two sides, so this side is worth 15. So we go ahead and do our Pythagorean theorem. H squared plus 15 squared equals 30 squared. Go ahead and pause the video while you find out what the height is. And when we get our height, we got our 25.98, and that 8's going to tell the 9 to round up, and the 9's going to tell the 25 to round up. So we're going to just put it as 26.0. So we know it didn't come out as 26 even. So now we have our height, and we're going to times it by the sum of our bases. And then we're going to divide by 2. And if you punch that into your calculator, we end up with our area of 1,118 centimeters squared. All right, take a look at this next one. Kevin designed a deck shaped like the trapezoid shown below or off to the side. Find the area of the deck. Well, I notice here that we're missing this top base, and we need to find that. So we're given both the sides, and so we have our height, which is our 4, and we need to find that distance. Well, the distance below is 9, and I can't say that I know that that x distance is exactly half, but if I drop this down, and if I can find this distance, then I know what my leftover is. So here, this is 4, and if I bring this down as perpendicular, and let's change that from x because we used x above. Let's use y. So now I can find that missing side. Hey, looking there, it's a right triangle, and I see one leg's 4, and then the hypotenuse is 5, so that's one of my Pythagorean triples. My y is equal to 3. So if that portion there is equal to 3, I know this is going to be 6, and so is my top base. So now we can plug into our formula. Our height times the sum of our bases, divide by 2. Punch that in your calculator. And we end up with 30 feet squared for our area. All right, Emily designed the silver earrings shown that are shaped like isosceles triangles. What are our trapezoids? What is the area of each earring? Now this one, we are given our bases, but we're missing our height. And so this is going to bring us back to problem 2 and find the height just like that. So go back and look at the Ellis trapezoid handbag for help with that. All right, to the back side, areas of kites and rhombus. Okay, if we look at kite and a rhombus, they both have diagonals. They have one that goes up and down, and one goes side to side. Let's call that up and down one D1, diagonal 1. And let's call the one that goes from the side to the side diagonal 2. And these two share the same formula, half. Now watch this one. It's diagonal 1 times diagonal 2. Or we can switch that half into the divide by 2. Diagonal 1 times diagonal 2, divide by 2. So that formula helps us with kites and rhombi. So let's look at number 5. Find the area of the kite. Well, we have both of our diagonals, so if we multiply them and divide by 2, we're going to find that area. So go ahead, 8 times 15, divide by 2. Yep, we get 60 centimeters squared. Now looking at number 6, number 6 doesn't give us the full diagonal, but they gave us portion of it. These little lines here mean that these two sides are congruent. So this is 12, and then this one's also 10. If we add those, you're going to go ahead and get this one diagonal here is 20, and this diagonal here is 24. So now using the formula we just talked about, try that one out. Number 7, find the value of x given the area of the kite is 92 inches squared. Ooh, this one is where we are given the area and we need to find the missing piece. So diagonal 1 times diagonal 2, divide by 2, that's our area formula. So let's plug in what we know. We know the area is 92. We know one of the diagonals is 22 and the other one is x, and divide by 2. If we go ahead and we simplify that, we're going to times by 2 on both sides. So we get 184 equals, now remember that just cancels that out, 22x. We want x by itself, so go ahead and divide both sides by 22. And we get 8.4, and this one is going to have a label of inches. All right, number 8, find the area of the rhombus if RT is 24, so this whole piece is 24, and angle RST is 54. So this whole angle is 54. We need to find the other diagonal. That one's going to be a little bit tougher. Let me help you out by telling you that in a rhombus and a kite, we get 90-degree angles where the diagonals cross, where they intersect. So if I draw one of these out, so I'm just drawing maybe this one out. Let's fill in what we know. We know that this side here is 12, and this angle here is half of the 54, so it's 27, and we want to find this missing side. So think about that. Think about how are you going to find that missing side, and come with that for us tomorrow. We'll see you guys then.